Hello and welcome to Electro Nerds Academy. Today, we will be talking about loops. Assume you are assigned a task to declare all the pins of the Arduino Uno as output. It means we have to manually write the pin mode statement declaring all the 14 digital pins and 6 analog pins as output, so a total of 20 pin mode statements, which is quite frankly a tedious task. This task will become a nightmare once we replace Arduino Uno with Arduino Mega, which has 78 pins. But don't worry, loops got your back. Loops are tools that allow a program to repeat a piece of code multiple times. In this case, writing the pin mode statement. Every Arduino sketch has the main loop or void loop section. However, we can also incorporate additional loops to handle repetitive tasks more efficiently. In programming, we have 3 types of loops: while loops, do-while loops, and for loop. With a while loop, it will first check to see if the condition is true. While this condition is true, it will repeat the code until it's not true. Now let's see how we go about writing a while loop. A while loop is initiated by writing a while identifier, followed by the condition you want to be satisfied to continue the loop. The syntax of a while loop looks very much similar to the if statements, where if the condition is true, then it will execute some code. But since it's a while loop, it will repeat the code until the condition is true. When the program encounters a while loop, it will first check the condition. If it's true, it will start executing the code written between its 2 curly brackets. When it gets to the bottom of your loop, the program will go back to your condition, check if it's true, and continue through the same process until the condition is no longer satisfied. Now, let's rewind a little to explore how a while loop can resolve our initial problem of declaring all 20 pins of the Arduino Uno as output without the need to write 20 pin mode statements. We start by declaring a variable named count and assign it a value of 0. This variable will keep track of how many times the loop has been executed. Then we have our while identifier, followed by the condition. The condition is that the count variable should be less than 20, and since the current value of the count variable is 0, and 0 is less than 20, the condition here is satisfied, and the code within the while loop block will be executed. Inside the while loop block, we have the pin mode function. Typically, the pin mode function requires the pin number as the first parameter. However, we have written the count variable in its place, enabling us to set digital pin 0 as an output. Subsequently, the count variable is incremented by 1, and it is now holding a value of 1. With that, we have reached the bottom of the loop, so the program will go back to check the condition again. This time, the value of the count variable is 1, but still, 1 is less than 20, so the condition is true, and the code will be executed again, now setting digital pin 1 as output. The count variable gets incremented again, now holding a value of 2, and the same cycle continues. After a few iterations of the loop, the count variable will now be holding a value of 19, which corresponds to analog pin 5. Again, since 19 is less than 20, the loop will be executed, setting pin 19 or analog pin A5 as an output pin. After incrementing the count variable, its value is updated to 20. Now, when the loop jumps back to verify the condition is evaluated to be false, since 20 is not less than 20, and the Arduino will ignore the code in the loop body and continue to the rest of the program. Similarly, we can set all 78 pins of the Arduino Mega as output using the same code. We just need to replace 20 with 78 in the loop's condition. Do-while loops act in the same exact way as while loops. However, instead of checking for the condition before they run the code, they run the code first and then check the condition to see if the loop should run any more times. But what's the point of that? Well, imagine you want to run this code at least once. With a while loop, if your condition isn't met, you wouldn't be able to run this code at all. But with a do-while loop, your program is guaranteed to run the code at least once. And if it doesn't meet the condition, you will just continue on with the rest of your program. Now let's move on to discuss the for loop. The syntax of writing a for loop is completely different than while and do-while loops. We start by writing the for identifier, and within the parentheses we have 3 expressions separated by semicolons. The first expression is the initialization expression. The second expression houses the condition, which needs to be true in order for the loop to be iterated. And the third expression is the increment or decrement expression. To understand this, let's revisit our previous example where we initialize all 20 pins of Arduino as output pins. Now let's rewrite this code using a for loop. We know that in a while loop, the first step is to initialize a variable. Here also, the first expression is the initialization expression in which we initialize a variable to hold the loop count. In while loops after initialization, the condition is checked. Is the count variable value less than 20 or not? If this condition is true, the next step is to assign the pin as an output. If the loop is run for the first time, pin 0 will be set as an output pin. Similarly, in the case of for loops, after checking the condition, pin 0 is set as an output pin. In while loops after this pin assignment, we increment the value of the count variable. And again, check the condition if the value of the count variable is still less than 20 or not. The same principle applies to for loop. After assigning the pin as an output, we increment the value of the count variable and check the condition whether the value of the count variable is still less than 20 or not. If it is, we iterate the loop a second time. This time, since the count variable has a value of 1, we assign pin 1 as an output pin. Again, we increment the count variable, again check the condition, and again assign the pin as an output. The same cycle continues until the condition is evaluated as false. That's it for this video. Stay tuned for upcoming videos, and we will see you next time.